Hello. Welcome back. It's that time again. Another Tuesday evening at the agency with your host. I'm just kidding. Yeah. So last week and this past few weeks have really been about exploring the world of GUI programming in Haskell. What sort of libraries are available? How can we make, you know, desktop style native applications with Haskell? In this day and age of the web and stuff, not terribly common, I don't think. But at least in some industries, it still is pretty relevant and is a nice skill to have and a nice thing to be able to do if you want to be able to build cool tools, visual tools. So we've been doing that with a project I started a while ago, just noodling around project, nothing major, a console-based text adventure engine. And I designed that for running in a terminal on a console, text-based, all the UI and everything around that is built on that. We built it, we extended it. We extended it and we added a feature branch to this engine that adds a GUI. And the first library we tried out is Monomer. And in case maybe you're dropping in and you're new this week and you were here last week, it looks kind of like this does. It could still use some improvements, but it's like a minimum viable product here. We can still look at the front door, I think. Right, and then it tells us what we see there. It looks like it hasn't been opened in a long time. We can walk to the front door. All right, so we get some input there from the user. They press enter. That user gets sent to the game. It updates the state, renders a new scene for the user to view, and decide what to do next. And we also have some basic error handling here. Nothing pretty. We're just literally printing out the show of the Haskell types here, but minimum viable. Okay. Still in development. And if I was going to continue on with this, I would totally fix a lot of these issues and make it look a lot nicer. And there's maybe some plans to do that. But I was thinking that maybe this week and for the next couple of weeks, we will try to get this same project going on a different GUI toolkit and see if we can get it to the same state, roughly, right? Where we can get the scenes rendering into a scrollable area here. We can get input from the user. We can display some errors. So that if we were to continue down this road, it would be a pretty straightforward path to fleshing out the game engine and making it look nice. So with that being said, our good friend Barry, who was here last week, suggested Qt. He picked out the Qt, I think is how you pronounce the library. And it looks something like this, the README page for it. Now I've gone ahead and installed like the base Qt libraries development libraries on my system here in WSL2. And hopefully, I think I've got everything in there that we need. All right, we got a C++ compiler. We've got make, we've got Qt base. And now we're gonna try upgrading a branch on Qt and see if we can't get this papa going. And I guess the idea is just to see what the different approaches are, the trade-offs and benefits, and just show you that you can totally do projects, even desktop native projects with UIs. And the old Haskells. Some might have different trade-offs, and some may be better than others depending on what you're doing, of course. So we'll see. First things first, though. Qt, I don't think I've ever written a program using Qt. I may have to for kind of like a secret stealth project, but I've never actually done it. I've written applications against GTK before, but never Qt. Qt, as I understand it, is probably like GTK. We're huge. Huge library. Rather large, and a very big ecosystem of tools and libraries that work with it. It's got its own conference. That's how big it is. Massive. You drive a car, there's probably a Qt UI in it. You've ridden on an airplane, Qt UI. You've used any kind of software in a computer in the last 20 years, probably used a Qt application at some point. It's massive. So I'm a little bit terrified of getting it going, because whenever I'm faced with like a huge library with so much stuff in it, I don't get excited. I get terrified. Just the choice, the amount of choice you got to deal with. Do I use this thing? Do I use that thing? I don't know. What's better? Who knows? There's trade-offs. And like engineering is all trade-offs. And sometimes it gets exhausting trying to figure out which trade-offs to make. So hopefully this is going to go smoothly. Very, very smoothly. All right. So first things first, let's go to our project. Let's quit out of our little cool tiny library monomer version, and we'll create a new branch for our project. Let's go in here. We're going to start it at master, and we're going to call this one the Qt branch. Why not? Makes sense. Am I not right? Okay. Just checking on the chat here. Chat, let me know what you think. Tell me about your Haskell projects. We're also going to do kind of like an informal office hours, I think. Either tonight or maybe we'll do like a more official one next week. I don't know. Qt branch, here we go. Okay, let's update our package.yaml. If we're going to add a new dependency, we always got to add it here, right? Yeah. Qta. Yeah, we got all that. Building it, cool. Can we just stackage, really? That's maybe it's on stackage. I don't know. Qta, are you on stackage? No. Okay, so we're gonna have to probably add it. Qta Qt5, Qta generator. Oh boy. Uh-oh. Qta CPP Qt5. I don't even know. Do we need to install all of this? This package contains the C++ side of the bindings. Probably not. Qta examples. Also good. Well, it shows a Cabal install Qta. I guess that's the package. Well, we'll just go ahead and do that. And now it apparently like binds to Qt. Qt is written in C++. Not the easiest thing to bind with. C is a lot easier. But it seems to have like kind of some kind of C++ based FFI that we can use. Hopefully. Add it there. Get our build going. Start clean. File, watcher, start you up too. Oh no. I must have cleared out my GHCs somewhat recently. Maybe. I don't know why it's downloading GHC again. That's interesting. Good times. Oh, maybe maybe in our branch we updated the LTS. .16 might have. That's might what be what's going on here. Let's check GitHub. Yeah, the Adventure Engine. Yes. Okay, that's why. Well, let's just go fix that quickly. New GHC just landed, 9.2. Can't wait to try that one out. A lot of cool stuff in it. They recently finally added kind of like this pseudo new Haskell thing. One of the things I've always found, like with Haskell when I was starting out, is that there's like a plethora of language extensions, right? Tons of them. And if you go to like some random Haskell repository, you might see a bunch of them at the top of a file and go, oh my gosh, there's a lot of different new things to learn on top of the language. It's a lot of stuff. You wouldn't be wrong. But I think the subset of like all those different files that you visit, there's like a common intersection of all of them. And they released a new extension in GHC 9.2 that enables that subset. And so the community kind of got together and worked on that and got it going. So that's going to be a 9.2. So there's going to be a lot of language extensions. You don't have to like enable individually all the time, over and over for every project. Just have them available. Okay, so yeah, it's not in Stackage, of course, so we gotta add it to our stack. Our YAML extra dependent file list here. Extra deps. Oh no, I'm having this keyboard issue again. Why? Let me fix that quickly. That is under Power Toys. Windows comes with toys. Some of them are better than others, but not always the greatest. Okay, there we go. Turn that back on. Get back to work. Extra depths. Let's add some Qt. Oh, we got a raid coming in, folks. Incoming. Welcome, Identity GS. Identity GS is also a wicked cool streamer. You should follow him. Or them. I don't know. Okay, good night. Have fun. Thanks for the raid. Sweet dreams. We are building well, I had a project, Adventure Engine, text adventure engine, but it was built for the console, the text terminal. We spent the last few streams working on adding a GUI to it, which was pretty successful. And we used the Monomer library, and it was pretty cool. Tonight, we're going to take the same project from the same state that we started with the Monomer library. We're creating a new branch, and we're going to do it this time. We're going to try and get to the same point we got to the first GUI in Qt this time. So we're doing some Qt programming in Haskell today. We're going to make a native-looking-ish Qt app. I don't know how native Qt apps look on Windows or Linux or really anything. The Monomer library totally doesn't look anything native, but it doesn't try to be. Okay, Hoppy runtime, Hoppy standard. We added this one here too. A bunch of non-hack stackage available libraries. Oh man, a whole bunch. Whole bunch. Okay, hopefully this time... There we go. Everything's going to download and compile now off a package. Woo! Man, I'm still kind of scared because like Qt is so... it's so intimidating to look at Qt stuff. Like, it's just so big. But hopefully it's going to be pretty straightforward. While it's compiling, let's read a little bit more about getting set up with Qt and how we're supposed to like get started. Hopefully this won't be a thing, but object lifetimes, because some of them are going to be created probably in the Qt runtime and written in C++. You have to be aware of that. So objects returned from constructors are not garbage collected by default. Okay. Most of the time this is correct, because Qt's object hierarchy ensures that objects get deleted properly. Objects that aren't owned by some other object will be deleted. That will be deleted, need to be deleted manually. Okay, so that's what all the hoppy stuff seems to be about. foreign.hoppy.runtime. Okay. All right. We don't need to develop on the library. We're not extending it or anything like that. We're just trying to use it. So that's about as good as we're going to get out of this one. Go to the home page. Let's check this out. API documentation. Ooh, not a good sign. Oh, I tried it again, but it didn't work still. Okay. We may be on our own. I don't know how good this library is or how maintained it is. Let's just look at the stats. I kind of ignored the stats a little bit. I gotta be honest. I was just too excited to try this. Okay, let's see here. Okay, fairly well downloaded for a Haskell project. I mean, 56 in the last 30 days, not too bad. Last update uploaded earlier this year, so yeah, okay. Should work, hopefully. What do we got to do first to get like just a window going, though? I think there are a bunch of example projects, perhaps, which was a good source of finding out how things should work when we were doing Monomer stuff. So let's go check. Ooh, build dependency field. Don't like that either. Documentation not available. Oh. Sometimes this happens with Haskell libraries, you know. Yeah, this is the repository for the Adventure Engine, by the way. We're working off of master. The GUI branch is our Monomer branch. So if you want to attempt to build that and see and play around with it, there you go. It's there. Let's try and look. I think it's on, oh, it looks like it's on GitLab. Super. Qt. Examples. Source. So there's like a notepad clone maybe? Mm-hmm. Okay. Uh-oh. Oh boy, I'm not sure if I'm going to like this library too much, but we'll see. With scoped pointer. We're going to build a new Qt application. Choose new window. Show UI window UI. Yeah, this could be okay. This could be okay. Let's try and get that going. Looks like we're just compiling the binding libraries here. All right, let's get excited. Let's get pumped. Let's do this. Qt. All right. So we'll go... This is kind of like the entry point for executable. We could just not do that here, but we'll change the entry point to a different function we'll define in the library somewhere. Let's start a module in Adventure, just sort of like we did on the other branch. I'm just going to call it GUI.hs. Cool. Module adventure. .gui. Where? Okay. Let's see what do we got to do to get. So it looks like everything's really designed to be import qualified. It's pretty good choice to go with, in my opinion. What do we need for the paired pointer stuff to get a basic new Qt application going with scoped pointer? That comes from the Hoppy runtime. Super. We'll need that. Thank you. We're going to need Qt application. Yeah. What are the Q application? Sorry. Application. There we go. Getting import blindness here. Super. Okay. Cool. Q application. What else do we need for kind of a bare minimum main UI? Oh, look at this thing. Probably need something like that. New chooser window. A new chooser window is an IOUI. Create initialize widgets. Okay. QWidget.new. That could be our new window. Set window title. QTOG. No. Okay, that sounds cool. Let's steal that. Just call it run. With scoped pointer. Yeah. Get args. I don't know if we need get args. What is get args? System.environment. Yeah. We'll just do qapplication.new. Yeah, and that gives us a callback, I think, with the pointer. But they ignore it. In their example, we shall too. Window is a qwidget.new, qwidget.setWindowTitle to, well, we're going to call it Adventure Engine for now. And then we kind of call, so it kind of has like almost an object-oriented looking style API, which kind of makes sense. It's written in Qt, which is written in C++, which is all based on class hierarchies and widgets, things like that, composing them together. So, yeah, it kind of looks hues very close to that. QWidget.resize window raw. We kind of pass in the window we want to operate on. And in an object-oriented language, this would be like kind of an implicit parameter like this. You know, that kind of thing, but we're just doing it explicitly because functional programming is awesome. Super cool. And what else do we need? Okay, we got to show the window and QCore application exec. So we need QCore application imported as well. Bang. And UI window UI. What's that come from? QWidget.show. UI window. Where does that come from? Let's see. Right, so this returns kind of like this UI state sort of object. That makes sense. Monomer sort of had like, we kind of pulled out the game state object, or game state record as kind of our UI state for that library, which we could probably do here as well, it looks like. So we just create like the widget and and put it in there. I'm going to skip that for now, I think, because that just gets out the QWidget from this thing and passes it to QWidget.show. So we already have that with a window. That's our QWidget.new. So we're going to just pass window there. And then we got to like do QCore application .exec, I think was the final line there, if I'm not mistaken. Yeah. Super-de duper. Okay, cool. Well, we're still compiling here. It's going to be a little while. We got a few hundred modules to get through. Oh, my goodness. So, chat. Office hours. Let's do this. If anybody has questions about what it's like to work with Haskell, you know, professionally, whatever, in open source, just general Haskell questions, shoot them my way. It's all good. This could be all right. Like, I think this could be all right. And it looks like we connect up, instead of using like the Monomer style, like, which is more like the Elm architecture style. Architecture here, we use kind of like a more retained mode style, well, similar kind of thing where we use like what they call signals. Pretty common architecture, I would say. You find this a lot in UI libraries, in even a lot of game engines, JavaScript, though asynchronous signals, and these are probably asynchronous as well. Sent by the runtime and yada, yada, yada. So that's cool. That should look pretty straightforward, hopefully, getting us our input set up. Well, while else we're waiting, let's catch up on... Let's see what's up in Haskell Reddit. I don't know. Right, the 2021 State of Haskell Survey is out. I haven't filled it out yet. I probably should do that. The people who put that together are awesome people. They do it every year. It's really awesome. Data interval. Advanced interval manipulations. Very cool. Open and closed, finite and infinite intervals. Cool. Full numerical hierarchy. Even storable instances. Neat. That's a nice little bonus. Both strict and lazy. Okay. Intervals are one of those things that are very, very super simple to describe. And I think of myself, I've probably tried on a Sunday afternoon kind of thing to be like, I'm going to implement an interval library. Just for fun, just cause. And it can be pretty fun. Let's check this out. Nice. So it looks like they kind of set it up to follow the same sort of API as containers. Strict and lazy versions of everything. That's awesome. Relations and sets. Very cool. Open and closed, just using plain type constructors. Cool. Also, very nice. So that defines a closed interval. Left, right. Okay. Oh, I see how they're trying to do this. It's kind of funky syntax-wise, mainly because of Haskell's limitations on like what you can call like what characters are available for operators, I guess. But looks like this equal sign is the openness side. So this syntax is the more kind of traditional syntax for intervals if you're looking at like maths. So this is, oh, okay. So equals is closed, like a hard squared bracket as you'd use to say closed. Okay, and then where it's missing, that means that end is open, which means the value is included. I think is how it goes. All right. So if your L is 0, it can include 0 and everything else up to, but not including the final number in the range, which would be your upper bound. And the opposite. And then a fully open interval. Nice. Okay, cool. So null, singleton, extract singleton, member, not member, subset. Cool. Lower bound, upper bound. Some operators for comparisons. That's a little bit funky formatting in the notation there, but I think I get it. That's awesome. So the things I like to use I find I use intervals in like practical day-to-day work are for answering questions like, of all these sets of things at given point time t, how many of them were in a particular state? That's usually something I can determine with intervals, because I can figure out when was the lower bound would be when it was in the prior state, and the upper bound will be when it was in the final state. Or like I can get the duration as an interval of how long it was in a particular state, collect the set of those, and then see which ones intersect with the particular time t with overlaps. So which ones overlap that time. Things like that are come up depending on what you're doing and things. But I was working in like industrial automation, stuff like that. So it was like, how long were all the machines offline for, or how long were they reported as down or not available, that kind of thing. Cool. I like that. Upvote for you, friend. I like your library. I will try it out sometime. For the people here working with Haskell on a daily basis, I'm curious to know, what do you do? What is your job? I actually answered this one. I work at Mercury. We make fintech software. We do it in Haskell. I think we even might have some job openings. We've been growing quite a lot this year, so if you're looking, give it a shot. If you don't even know Haskell and you're just like a beginner, that's cool too. We hire lots of people and just teach them. And we have a whole team dedicated to that. So give it a shot. You might like programming in Haskell. But if you already knew, then you know. And that's okay too. Pair programming buddy wanted. Oh, me too. That's why I stream. It's like massively multiplayer. Only we're not a massive agency yet, but we will be one day. MLabs wants to hire some Haskell programmers. Symbiont wants to hire some Haskell programmers. Source line of code equivalence. I don't know about that. Haskell compiled to LVM increased performance. I don't know if it would. NF107 says that LVM is not slower than native code generators, so it usually makes sense for production builds. The issue is that LVM takes forever to compile. Haskell builds can be pretty slow already, as we're seeing here. Apparently Don Stewart from way back when, in the before pandemic times of 2010, says that there's mostly untapped potential there for optimizations with languages like GHC. That's interesting. I wonder what he might have been referencing. Okay, well, interesting stuff. We finally got compilation going. Let's see what our problems here are. Except, oh, that's weird. Okay. But that's easy to fix. We're just missing some imports for some reason on in here. I should probably also upgrade my language server. I don't think I've done that yet, which hopefully the new version's much faster and maybe uses less memory. That would be great. I really enjoy everything everybody's doing to make Haskell language server. You folks are dedicated and awesome and brilliant beyond words. I can't even make that sound good. How amazing you are. So there you go. Yeah, we just need control.monad.accept, I think. .accept. Monad exception. Why aren't you in? Oh, that should have brought both of them. What library is it? Oh my gosh. My dead brain. What library is that again? Come on. Come on, Hackage. What is it? It's the MTL one, right? Maybe that was the wrong thing. $44. I'm going to throw, I think it's from that one. I'm going to add error. And monad error needs the error type. Weird. I don't remember having this problem on the, excuse me, monomer branch for some reason, but maybe my memory is fuzzy. Oh, I did, but I fixed it. Okay, cool. Monad error. We don't need this. Right, we just need monad error with our that. And then the E. Da, 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 da. Just like that. I don't know. Sure. We can't throw IO, we throw error. That should be fine. Okay. Back to y'all. Okay, so we have to add hoppy runtime as an actual dependency, which we didn't do. That makes sense. Hoppy runtime here. Rebuilding there. And we got to import Q widget. Cow. Yeah, we didn't do that. Qta. Q widget. All right. Now, what's this one? Oh, new is applied to too few arguments. Oh, that's too bad. What arguments does it need? I suppose that's probably what getargs was providing in the example program that we didn't understand why. QApplication.new. I guess the text string probably. What do you want? Put a hole there. You want one argument. What is it, GHC? Tell me, please. LSP restart. Okay, so it wants some arg10 of an ambiguous type variable. Very helpful. Very helpful. List of string, perhaps. I can't figure out that it's supposed to be a list of strings, so put an empty one there. Now it knows because inference is working. All right, we dialed in. Success. Built. Okay. Oh, wait, we didn't, we'd have to update the main. So instead of the text console REPL input point, we're going to use the GUIs input point, main entry point. Entry point is usually what people call it, I guess. Whatever. We call it run. That should do it. Obviously don't need engine in there. Yeah. Cool. So now, let's see if we get a window. Oof. Oh. Another thing, and because we're using foreign bindings to foreign objects, we need to dynamically link to those objects. libqta there probably compiled a share object file with a whole bunch of information about like where in the shared object file to find this function and the how to marshal the types back and forth between C++ and Haskell, which means we need to set some compiler options to compile our project properly. And I think they document that somewhere. Enable executable dynamic. Yeah. So hopefully we just default Qt5 because that's what I got installed, right? How do I tell it to link dynamically? GHC options dash dynamic. Okay. Let's go to the package.yaml. GHC options here. That's where you set your compiler options. We can just do that here. Dash dynamic. And now, hopefully... there we go. Suba dupa. We have a window. Can resize it. That's cool. It has our window title on it. Cool, cool. All right. Qt window complete. Next. Now that we got a window, we got to display something in it. So let's get a, I don't know, like another kind of widget and display it on there. Okay, what widgets do we have available in Qt? Probably quite a few. Base Qt, I feel like, has a ton. QVector, widgets. Abstract button. Abstract item delegate. Abstract item view. Abstract scroll area. Cool. Well, we need a scroll area of some kind. Maybe we'll end up using you, but for now, do we have like, let's see, a tree view, tree widget, tree view, no. VBox layout, cool, all right. Like a label. Label, Q label. Let's try that. Yeah. Oh, I didn't want to open it. What am I even doing? I don't know. Brain's kind of going, whatever, you know. Okay, we need to import that. Q label. Okay. Let's try it. QLabel.new. IOQ label. Ooh, there's another one. New with parent. With text and parent. Couple of constructor functions there. Nice, nice. Maybe parent should be window. Let's try that. It's probably window. Text. Or is it the other way around? Oh, maybe it's the other way around. Ding, ding. Kind of like the way it's spelled out in the function name. Let's put hello world in it, see if that makes a difference. Okay, cool. Boom, text label, done. Now we need to make a bunch of text labels. And in order to do that, we could pull in our game state. And pull in our game, the next step, we should pull in the game state and just display the initial scene in a text label. That's it. Small steps, small steps. Okay, so that's in the engine. I like to put those after kind of like those imports. It's like our local imports. I don't know if that's what you call them. But adventure.engine. And it's got our game state in there. And I think it's called default game state. And then, let's see, our text for our label. Now to get the initial game state view, it has some functions for rendering the scene. Let's take a look at those right now. There's a little peep. Right, okay, cool. So this is our game engine monad that runs the console version. We're using this game state record here for now. It's got a world, a list of commands. There's render function. It takes a world and either gives us an error from the game or some text, i.e. the rendered scene. So let us get that. Let's do that. Let's just, I don't know, bind it to scene for now. We're probably going to get rid of this code and, you know, modify it. But for now, one step at a time. Render. And we'll get the game state world out of GS. Of course, that'd be silly if I forgot that. Game state. Watch out. Let's just underscore game world. Poorly named, but there you go. Watch out. Okay, so that builds. Now that's an either. Two. Let us map on it, and we'll just render if there's it's probably not going to be an error, but you know, if there's an error, we'll just render it out using the show instance for the left and just ID for the right. Now that's going to be actually show's going to return a string, so we probably need to make that mix that with a text. T.pack, and we'll just import qualified data.text at the top. And up here. Data.text. Qualified as D. That's bimap. Probably in data.either. Also, or it's probably either in data.either, but yeah. Cool. Okay, so that compiles, and now we have a rendered scene that we can stick in that label. And man, I think LSP is killing it right now, so I'm going to just shut it off. Is our stream still online? You with me, chat? Good stuff. Okay, let's just turn off LSP mode. Oh man, it is really crawling here. No good. Okay, we're just gonna have to kill you. Sorry. Oh, sorry, that should have been dash S. Prepare. Okay, bring it back. There we go. Yeah, I don't know why I'll try updating LSP, but it's on this project. It's just, it gets slower and slower. So maybe I'm just going to quickly go into my Emacs and just not load it. It's, there we go. Just temporarily turn it off for now. Okay. Oh. I don't know if I can run it from there. No. There we go. Okay. Skadoosh. Okay. Fair. Engine. Adventure. Engine. Okay, there we go. Okay, cool. Stack build fast. File watch. Okie dokie. Now, we're back in action here. Game state. We're about to render the game world, at least the initial one here in this label here by just using scene. This doesn't like it because text. Oh, it actually wants a string there. So instead of packing the show, we can just use show. But the ID instance for this should be t.unpack. Okay, I'm just flipping around a little bit. Okay, cool. So here we are. We've got a window. We've got the first scene being rendered. No input yet, but we can get there. And then, yeah. So the next thing we're going to do, I guess, is maybe we should do the input next. And you know, I was kind of getting the heebie-jeebies being like, oh, QT at the beginning of this, but interfacing with foreign code from Haskell can be pretty nice. It can be. I mean, always marshalling objects through an untyped interface is kind of like, meh, but it can be done. The reason why I think it's kind of nice in Haskell is that like a lot of things are very explicit and declared here. So there's lots of opportunities to leverage Haskell to like control things like scopes and stuff, and maybe not so much lifetimes without linear types, which are available now. I haven't used a whole lot, but that's another avenue for using, again, leveraging some features in Haskell to like you give yourself even more assurance that you're using those pointers appropriately and not leaking, data and things like that. Leaking them pointers and leaving them hanging and not properly cleaning up data. It's also known as a memory leak. That looks good. So input, how do we need a widget? We need a new widget. We need an input widget like a text field or something, which I think we saw down here. Text edit, not so much. Maybe text edit. Maybe it's like named something like input not a dialogue. I don't want an input dialogue, I don't think. Line edit. Spin box splitter. Okay. I mean, we could just take a stab at text edit and see what happens there. Yeah. Label. We'll leave you there for now. Input area. We're gonna have to import you. Yeah. Leave a hole there. Yeah, I want it up here. Q text edit. So we'll set that to Q text edit dot new. With parent. The downside of not having LSP is not having those completions. But there you go, it worked. Consistent API naming is great. Also a way to make things discoverable, for your users if you're ever writing a Haskell library. Or just a library in general. Be consistent in your naming. That's all. Okay. What does that even look like? Let's just run it. See what happens. Okay, so it is kind of like a multi-line input. I got some text like this. Thanks for the follow, Zombie Killer 4. You made a great decision today. So if you haven't followed me yet, click on that button. You'll get notifications if you set that up for when I start these streams. I only really do them once a week, so I'm not really going to spam you with a whole bunch of notifications. But then you'll know when I'm going live. So text area looks like kind of not exactly what I want, unless there's a way to configure this to be like one line, and that's it. That's what we want. Right. I kind of want to stack it so it's underneath the label, laid out properly. But progress is progress. Okay. I don't know what this Qtod GUI part is. Looks like events and things that interact with the GUI. Maybe we have to do a little Qt Googling. Single line text input widget. Qline edit class. Okay. Do we have a Qline edit? Qtar. We do. All right, let's try it out. Oh my god, why do I keep doing that? I did it once, now I keep... Ugh. Like my brain has suddenly remapped that to copy for some weird reason. Stream brain is real, friends, if you ever want to try this. It's fun. But wow. Qline edit. Let's get rid of text edit. Let's get out of there. Qline edit. That's probably more our speed, isn't it? Oh, look at that. There it is. All right. Okay, cool. And then we press enter. It doesn't do anything yet, but we will. We'll make it do something. Cool. So let's get some layout going. How do I do layout? We saw some widgets. I don't know if like widgets are the way we want to do it. Maybe. I don't know what XML stream stuff is. Ugh, scary. Q threads. Oh no. Don't get me on Q threads. Q list. Maybe it is widgets. It's all widgets all the way down. Anything visual. Anything you see is a widget. Even if it's just a meta widget that just lays out things. Okay. VBox layout? Probably. Oh my god. It has. VBox layout. Okay. Lines up widgets vertically. Okay, so we create a new layout, we add widgets. What's kind of nice actually about this binding too is that, like I was saying earlier with the object-oriented thing, makes translating this stuff. Let's see if we can just translate this almost directly into how we think it should work, and maybe it will. Okay, so QVBox. QVBox layout as QVBox layout. Okay. Is a QVBox layout new. With parent of window. Okay, now the parent of the label will be the layout. Although that might not work anymore. Let's see, Haskell's already telling me that I'm like doing something silly here. Hopefully. Yeah, so like I'm not passing in the right pointer thingy. Okay, so label, though, if we're right about this, has an add widget method, but in Haskell it's not really a method. So I wonder how I access that. QVBox layout. Add widget. Ooh, no. Let's create the QLabel first. Just with text. And then we will call QVBox layout. This seems right. Oh, it doesn't export to add widget. Okay, maybe not. Well, how does it work then? Qta, unfortunately, the haddocks are broken, Qta. Fortunately, we have the source. Is it core? No. Where are we here in the source? This isn't right. Yeah, grabs Qta, Utah. No. Do we have a search function in GitLab? Yeah. QVBox layout. Show me the code. Where is it? Oh, for some reason, at least in this example, it's got QBox layout. Dot add widget. Okay. Okay. I guess that's how it's supposed to go. So QVBox layout doesn't have add widget, but QBox layout does. So we'll add that up here. There's QBox layout. And then our layout and our label. Cool. And we'll do that again with add widget, layout, and input area. Just like that. It's a happy little input area. Yeah, I know data is kind of redundant here, isn't it? Okay, let's try that. There we go. All vertically laid out, kind of like our last UI with Monomer. All right, so it's looking fairly familiar. Nice. Nice. Okay, next step. Let's see. We should probably figure out, I guess we need to figure out how to get input going. So when the user types in their text, presses enter, we want that to update the state of the game engine, render a new scene. We actually want to have like all of the scenes that we've rendered so far available in a list for that scroll buffer. So we need to have more than one text label and be able to like kind of stack them in a list. So we might need to do a little bit of sculpting here, a little bit of moving things around. And what we're going to do is we're going to kind of do, I think, the way we did it with Monomer as well, which was to just expand the game state to be like our kind of UI state between the engine and the UI, what we're displaying. So game state, scenes, just a list of text for now, should be fine. And then that means we need to update the default game state. Put it in that order there, yeah. Clean up there. Thank you, H-Lint. Okay. Very good. Okay, so now when we get the default state, let's initialize that. Let's have like a constructor function that kind of like takes the default state, does the first initial render, and adds the first rendered scene to the game state, and then returns that as the initial game state. Where did I put default game state? Why did I put it so far away from the type definition? I don't know. I'm gonna move it up though. And then we'll have like initial game state. Okay. And so what we need to do is kind of do what we're doing in the GUI at the moment, which, yeah. And that's this line here. We're rendering the scene out. I'm just going to pull that straight out. I'll make scene just empty text here, just so that that doesn't throw us weird type errors while in the middle of this. Cool. So our let binding binds our scene there, our first rendered scene. Then we just have default game state, where the game state scenes is equal to just scene. Oh yeah, geez. Also default game state. And we do want text here. That's going to be kind of annoying. But it's there. Okay, it's kind of what's kind of annoying me right now is just that the Qt label takes a string and not a text. Whereas I use text in the game engine internally because it's just a better type for that sort of thing. We're building a game engine after all with its a text adventure engine, so you should. But maybe there's text variants. I don't know. Or maybe we can do a pull request and add instances to it if we really wanted to use this library. Let's see, just checking on chat, see how anybody's doing. If anybody's got questions, by the way, again, informal office hours tonight, so feel free to pop in there and just ask away. I'm just kind of continuing on here, messing around, finding out. Okay, what's our type error here? None? No, we're good. Okay, so initial game state now. Let's change that to init game state. And then scene, instead of us rendering it here in the GUI directly, we should come up with a way of rendering those out. I'm wondering if the good approach here, the Qt approach, is that our game state should, instead of keeping the list of rendered scenes as text, just keep the rendered list of widgets, rendered labels. That would tie Qt deeply into the engine, y'all, which I don't like. So, nah. What we'll do, though, is that I don't know how this is going to work exactly, but we're going to figure this out. We'll create a list of labels from the thing, and then we'll add them to a vertical box that we'll put in a scrollable area. One thing at a time, though. Yeah, let's get rid of scene here. There's going to be a problem for you and a problem for you. Now, main layout, that's kind of like our main layout. Let's create a new VBox layout. That'll be our rendered scenes. Scene layout. Sounds good to me. Q VBox layout. New with parent. When yeah, window. Sure. No. Just new. Just new. Okay, so now we need to iterate over our rendered scenes and create labels. And I think all of these are monadic actions in IO for the most part, so we should use monadic 4. I might need to import that. And for all of the game state scenes, GS, we are going to Q widget, or no, Q box layout. And then we're going to add widget. we're gonna do two parts. We're gonna create the label for the scene. A Q label, new with text. Might not need to do a t dot unpack that to a string. And then add that label widget. And we import control monad. And that's, sorry, layout, scene layout for the label. Cool, 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 cool. All right, that compiles. Let's run it. I don't see our initial scene text in there yet. Oh, I know why. We probably didn't add that scene layout widget to the layout. So QBox layout, add widget to the layout, scene layout. Does that work? Okay, so types are saving us again from doing silly things at compile time rather than at runtime. But we have no instance for widget pointer for VBox layout. So it looks like we can't add a VBox layout to another VBox layout. We can't like nest them inside one another. That's what it looks like to me. That's what the types are telling me, yeah. So what can we do, Qt? List view. Layout item, maybe? Q list view provides a list or icon view and what I want. No. Nope. What's the other one? Layout item. Maybe there's more about VBox layout and how to add nest layouts. I should look at the documentation, see what we get. Okay, the layout is set directly as the top level layout for a parent. There can be only one top level layout for a widget. What does that mean? There's only one top level layout for a widget. Oh, there's a stacked layout class. Oh, we'll need stack. Okay, that's not quite what I want. Layout management? I don't know. Okay, the Qt layout system provides a simple and powerful way of automatically arranging child widgets within a widget to ensure that they make good use of the available space. Okay, I mean, that sounds good. How do I do it? So I got a box layout. Yeah, we've been using VBox layout. That's good. Okay, maybe, yeah, maybe we're not doing this whole. So this idea of using labels inside of a VBox layout and nesting that VBox layout inside of another VBox layout is something that worked kind of for me in Monomer and this project, but I guess we need to use something else in Qt, like a list. Should look into that list view. Maybe that's like an actual widget we can line something. Or list. Item-based list widget. Let's see. No. No, it's not what we want. Mm-mm. What else looks like? Maybe we should use a text area. Probably won't look quite as nice. It'll look a little enterprisey, but it might work. Yeah, I'm not really seeing anything else we can use here, chat, so I think that's the way it's gonna go for this one. A big old text edit area. Okay. Should have been checkpointing along the way. I'm totally off my rocker here. Because backing out of this code now is going to be kind of annoying. But not too bad. Not too bad. Just get rid of that. Get rid of the scene layout idea. Too bad, scene layout. It was nice knowing you. It would have been super sweet if that was the way it worked. But too bad. Okay. So now instead, we're gonna have to like combine all the rendered scenes into some text and render it into this text area widget, I guess, is the gist of it. We might not even need QLabel anymore. So let's try that. Hopefully there's a way to disable text editing with it, so that our user doesn't, you know, muck around with it. It's our art. You're not supposed to be able to. Okay, import qualified graphics.ui.qta widgets q text edit. It's q text edit. Like we did at the beginning. Okay. Scene. The scene widget will be a q text area dot new with text. And that will be with the game. I guess t dot. There's a text function for this in data.text onlines with game state scenes of GS. Oh, Q text edit, sorry. My bad. And we have to unpack that down to a string. So silly. Okay. Q box layout. Add widget to the layout with our scene. That should compile. Let's make sure it actually runs. Okay. This is our Qt version. It's looking kind of nasty in here. We can still select the text. We can mess it up. It's got undo support. That's nice. Okay. So we're going to have to, like, I guess, manually manage rendering into this text area. We have a little bit of time left on the stream. Let's just see if we can turn off text editing on it. Q text edit. Which kind of defeats the purpose of the whole class, but I don't know. It has a bunch of properties. I don't know how to set those in the Haskell side of things, but it's there. Can paste. No. Current font. Cursor for position. Ah. Is read only. Okay. So it has a property that allows us to do that. Qta. Do you have a way for us to set that? Let's see. Let's search you. Q text edit. Okay, maybe. Yeah, it might work that way. Set this, set that. Set read only. Let's try that. Q text edit. Set read only. Scene. No. Oh, scene false. We're just missing a parameter there. Or no, we want true. Okay, cool. Cool. Yeah, I can't edit it now, so that's perfect. That's what we want. And you can, you can select it, so you can like copy and paste out your text. Control A, copy context menu. Nice. Nice, nice. Gotta fix the rendering, but I mean, it's all right so far. Not bad. Let's checkpoint here. Wow, we did a lot of stuff. Big change right off the bat. Add basic Qt UI. Added input area to accept user input. And a text area. Read only. To display scenes. Okay, pushing that up. There we go. Qt branch. You know, I think it was Simon Peyton Jones said that. I might be wrong, so correct me if you know this quote. That Haskell's like the best imperative language, which is kind of odd. This isn't too bad. Like as far as imperative stuff goes, like I imagine if we flip the lines around here, right? Add this widget first, and our second, it would change where it shows up, at, you know, in the thing. And we saw a couple places where we tried to, you know, add widgets that don't really belong to other widgets, and we got type errors from that. Like they're okay type errors. It could be maybe a little bit better, but they're decent. So this is pretty okay so far, I think. Next week we'll continue on. We have a little ways to go in order to get this to the state the Monomer version branches on, and try to get feature parity with between the two. We still have to handle the input, update the state, render. We got to fix the rendering for that, so we can scroll back through the history of the game and see all the different states and stuff. And we need to be able to display the errors somewhere, so we'll need some way of doing that as well. Thanks for tuning in. I usually do these streams once a week on Tuesday evenings, about 8-10 p.m. Eastern Standard Time. There's a Discord. There's an invite link above my head and above the chat. And if you're interested in coming and hanging out and chat between streams or just chatting in general, we have a channel for this stream there, as well as others, because there are other people who are streaming Haskell and other declarative/functional programming languages all the time. And there's a great community on that server, so check it out. You can also follow me on the Twitters. I'm Agent Ultra there, and of course on GitHub, where this code is in Adventure Engine. I'm Agent Ultra on GitHub as well. Like stars, all those things, appreciated. Just because they're fun, whatever, doesn't matter. But go ahead, start if you want. And then there's our Qt branch. Yay! I'm also archiving our videos on YouTube. So if you're following this channel on YouTube, hello YouTube friends, like and subscribe and all that stuff. I don't think it's Agent Ultra there. It's J. Kenneth King. All one word, lowercase, pretty straightforward. My recommendations are terrible, so... But there you go. May all your monas be free. May your types always check. And we'll see you next week as we continue on exploring GUI programming in Haskell and all the different available libraries to us. Have a good week. Take care.